Hello everyone. Your today experiment is an elimination reaction. Synthesis I have cyclohexene from cyclohexanol. So the reaction is an E1 reaction. The first step of the reaction is similar to the first step of the SN1 reaction, tertiary butyl alcohol to tertiary butyl chloride. But here cyclohexanol uh, uh, undergoes to an elimination reaction, not substitution reaction, because here the main reason for this phenomena is that here we have a heating step, but in a substitution reaction where we convert tertiary butyl alcohol to tertiary butyl chloride, we had no heating step. So your reaction which you're going to do today is using cyclohexanol and sulfuric acid to have cyclohexane and water as products. So elimination reactions are important as a method for preparation of alkene. And so when we have, for example, a single carbon-carbon bond, so during the elimination reaction, we'll have a double bond. And if we have double bond, we will have a triple bond of carbon-carbon bond. So the term elimination describes the fact that a small molecule is lost or removed during the process. For example, during our today experiment, an alcohol group will be removed. A 1,2 or beta elimination indicate that the atoms that are lost come from adjacent carbon atoms. So, for example, here for our today experiments, the OH group, the alcohol group will be removed. That's why it's an elimination reaction. So another thing is that the rate of the reaction has a direct relation to the concentration of the substrate, which is cyclohexanol here. And so the relation, the reaction is order 1 reaction. That's what we call it E1. And so acid catalyzed the hydration of alcohol to alkene. So that's why we are using sulfuric acid here. It's kind of catalyst of the reaction. So about the mechanism, the first step is protonation of the alcohol group by the acid. And then in the second step, we'll have removing the water. And then at the last step, the step 3, so we will have the formation of the double bond. So about the procedure, at first, you need to clamp a 25 round bottom flask to a ring stand in the hole. You need to use a ring clamp. So, and then you need to add 5 milliliters of water in the round bottom flask, add 4 milliliters of concentrated sulfuric acid. And so for using sulfuric acid, you need to be careful because it's a concentrated acid and it's kind of dangerous. So the mixing in the step 3 will get hot. You need to use hot plate to heat your mixture, and then cool it for 20 to 25 Celsius in the room temperature. So then adding about 3 grams of cyclohexanol slowly to the mixture and add 3 boiling chips to release the formed bubble, gas bubble from the mixture. So that's the target of adding boiling chip to the flask. So let me explain the procedure step by step again based on the some figures. So here at first we need to assemble a distillation. So the distillation which you are using here is an azeotropic distillation. So Here, as you can see, we have the round bottom flask. You need to clamp it by using a ring clamp. So calcium adapter, the distillation head, the thermometer adapter, thermometer, and so the condenser. So you need to collect your product in a test tube. You can put it on an ice bath to increase the rate and the increase the speed of conforming of the uh, vapor to liquid. So uh, here again, so after collecting your product, you need to remove the lower phase, which is an aqueous phase, and you don't need it, but the upper layer is your cyclohexene layer. You can use a posture pipette to remove the bottom layer. So after removing the bottom layer, you need to use sodium carbonate uh, to wash your products. As the target of using 10% sodium carbonate is to neutralize the remained acid in your product, cyclohexane. So for washing by using 10% sodium carbonate solution, you can use the scoriating technique, which I've explained in some of our previous experiments. So you can do it 12 times to be sure that you completely remove the rest acid in cyclohexane. So after that, you need to remove the sodium carbonate, which is an aqueous phase, and it will be the bottom layer. You will remove it and add 1 milliliter tap water, and again doing the squirting technique to wash the cyclohexane by using this 1 milliliter tap water. And then again removing the bottom layer, which is the water layer, and adding 0.5 gram anhydrous calcium chloride to dry the cyclohexane to remove uh, probable remained water drops in the cyclohexane. That's why we are using anhydrous calcium chloride. So you need to uh, swear and wait 10 to 20 minutes for to be sure that you dried your product. So after that, you will have your final product. However, you can use the simple distillation uh, and collect your product in the adapter, a calcium adapter here, as you did it previously in some of your experiments. But it's not necessary. It's up to you to. It's you can do it to have uh, a more pure product. So at the end, you need to do some tests to be sure that you have the cyclohexane in your product. So one of the method which you can do is some unsaturation tests. So for example, here we can do two types of unsaturation tests in OChem lab. The first one is using potassium permanganate test. So you can add potassium permanganate to your mixture, to your solution. So purple color will change to uh, colorless solution with some brown precipitate, which is magnesium oxide. So in the second test is bromine carbon test by after adding the red or brown color of bromine color will be colorless. So here we have some image, so you can see for bromine chloride test, the brown color will be colorless, and for using potassium permanganate, so the purple color will be colorless. So in this way, if you could have this conversion of the color brown or purple to colorless, it means you have an unsaturated compound in your mixture, and here the unsaturated compound is cyclohexene. In this way you can prove that you could synthesize and cyclohexene from cyclohexanol. So about the safety, as I already mentioned, the most important thing is that you are using concentrated, high concentration of sodium of sulfuric acid, and you need to take care about it. You need to take care about it. And in addition, most of the reagent which you are using are volatile, so you need to do all steps of the experiment under hood. So about the analysis, you can weigh your sample, calculate the percent yield, temperature range of the distillate, target range is 77 to 83 Celsius, and so you can do some tests by using IR and NMR for your product. That was your today experiment. Take care, guys. Good luck.